our discussion topic for this day. So we are going to talk about preparation of salts. We have already talked about preparation of soluble salts. Now we are going to talk about preparation of insoluble salts. And we said for you to prepare insoluble salts, you can either use two methods. The first one is what you call direct synthesis. We've also discussed about it in another video. You can check it out. And now this method that you call precipitation reaction, double decomposition, or double dissociation. So this method we're saying it is also referred to as, you can call it precipitation reaction, double decomposition, precipitation reaction, you can call it double decomposition, or you can also call it double dissociation. So we are saying double dissociation because we are going to have exchange of anions from one salt to the other. Now, so how do you prepare an insoluble salt? The first thing you do is you take, we say again another thing during preparation of an insoluble salt in precipitation reaction or double decomposition, you're going to use two soluble salts. So this whole process involves what? It involves two soluble salts, okay? So you react two soluble salts for you to get one insoluble salt plus another soluble salt. So that is double dissociation. Now, what do you do in terms of preparation? You take one of your soluble salt, and remember this salt is going to be in solution form because it is soluble. So you take one of your salt, which is soluble, you put it in a beaker. You add an excess of the second soluble salt in the beaker while stirring with a glass rod. Now, after you do that, you are going to see the formation of solids or precipitates, which are solids, indicating that you have formed what? Your insoluble salt. After you do that, after you have seen that solids have been formed at the base of your beaker, you decant the liquid, wash the solid with distilled water, okay, and then you dry the solid between filter papers, and that is how you form your insoluble salt. Now, in formation of an insoluble salt, what is expected of you? So you're expected to know how to write the equation of the respective insoluble salt that has been formed, and you're also expected to write an ionic equation of the formation of that salt. Now, what is an ionic equation? So we say an ionic equation is an equation that is obtained from writing only the ions that undergo change. That do what? Undergo change in a chemical reaction. So when you react these two salts, lead nitrate and magnesium sulfate, barium nitrate and zinc sulfate, you're going to form your insoluble salt and a soluble salt. And you're expected to write an ionic equation. So the ionic equation, you're going to write it, and you're only going to use the ions that undergo what? The change during the whole chemical reaction. And that is what we're going to learn right now, how to write the balanced equation of preparation of insoluble salts and writing of ionic equation. So you need to know another thing, that is spectator ions. So when you're writing an ionic equation, you're going to be guided by spectator ions. So what are spectator ions? Have you ever gone to a football match, or have you ever watched any match? Yes, you have. So you sat and there were the players who were playing. So you were watching, you were a spectator. So how you came in that match is how you left. But these players, they came in clean and then they left, well, they were dirty, they were sweaty, they were smelly, probably, I don't know. But like, it's not the same the way they were initially. So this is because they were doing work, playing the games, football, soccer, like tennis, whichever game, that sport that they're playing, it involves energy. And they're going to become a little bit sweaty or dirty, maybe they'll fall, they do. So those people play and you watch. So the way you came in, unless you dirtify yourself with, like, maybe you pour juice on yourself or popcorns or whatever, like that is the only time that you're going to dirtify yourself. But how you came in is how you're going to live, because you're a spectator. So also in equations you have spectator ions that are just there. It's like they're relaxing, they're not doing anything the whole process. So spectator ions don't change during a chemical equation. Okay, what happens is they retain their state symbol, and that helps us to know that they didn't change. Now, so spectator ions are ions that do not change their states during a chemical reaction. So these spectator ions are the ones which you're going to remove, okay, because they did not take part in that reaction, and you're going to remain with only the ions that took part. And that is how you write an ionic what? An ionic equation. So let us proceed. So here we have the reaction between lead to nitrate, which is a soluble salt, because we say all nitrate salts are soluble, okay? And the reaction of magnesium sulfate with lead to nitrate, because we said, what about sulfate salts? We said all sulfate salts are soluble except calcium, lead to sulfate, and barium sulfate. You remember that? So we have these two soluble salts reacting to give us the insoluble salt. This is the process that you're going to use, okay, if you're doing it physically in a lab. Now let us write the chemical equation. So you get lead to nitrate, and we said this process is called double dissociation, decomposition, because we have the exchange of anions. So here another thing that you need to know is it involves exchange of what? It involves exchange of anions. And what are anions? We say anions are the negatively charged ions, okay? So you also need to know that, so that you can be able to write these equations properly. So which are our anions in this case? So here we have this is the negatively charged ion there. So because lead is written as 2 plus, because it is a positively charged ion, okay, and then the nitrate, and then we have nitrate ions, which are negatively charged ions, okay. And then in magnesium sulfate, we have the magnesium ions, which are positively charged, and you have the sulfate ions, or the sulfate radical, which is negatively what? Charged. So we say we have an exchange in anions, meaning this nitrate anion, which is negatively charged, is going to come on this side, and this sulfate anion is going to come on that other side, okay. So that is what we are talking about when we are saying we are going to have an exchange in anions. So let us write the equation now. So lead to nitrate plus magnesium sulfate, let me rewrite it again. So you have lead to nitrate, you react it with magnesium what? Sulfate. You're going to have the exchange of anions the way we said. So you're going to form lead to sulfate, okay? And you're going to form magnesium nitrate. And we said all sulfate salts are soluble except lead to sulfate, barium sulfate, and calcium sulfate. That's why we're writing here solid, indicating that that is our insoluble salt that was to be formed. Plus magnesium nitrate. Magnesium is going to take this anion. We said they are going to have an exchange in anions. So plus magnesium magnesium nitrate. All nitrate salts are soluble, so we are going to write here aqueous because they are soluble in here. So we come back here. Now we are going to write the ionic equation. We say that is what is expected of us, and ionic equation we said you're going to write it by checking the spectator ions and removing them because they did not take part in this chemical reaction. So First, we are going to break the ions. We are going to write all the ions present in our reaction. So what are the ions present? So here we have the lead ions. Okay, we have plus the nitrate ions. Plus the nitrate ions. Also indicate the state symbols because it is important. Plus the magnesium ions here. You add the sulfate ions also to give you lead 2 sulfate or lead sulfate plus magnesium ions plus nitrate ions. Okay, so after we've done that, we are going to proceed and we are going to balance the equation by putting a 2 here and putting a 2 where? A 2 there. We talked about balancing of equations. We also have a video of that. You can check it down there. So you do it like that. So after you've done that, we've said you're going to cancel the spectator ions, the ones that did not change. Okay, so ni gani hazikubadilika? The ones that didn't change retained their state symbol. So here we have this one. Lead ions here are aqueous. Lead here we are solid. Nitrates, the aqueous here, nitrates are aqueous here, so they did not take part, thus they didn't change. We cancel them. Magnesium is aqueous here, magnesium is aqueous here, so it did not take part, so we cancel it out. It is a spectator ion. And now we remain with the ions that took place in our chemical reaction, and that is going to give us the ionic equation. So we are going to write lead ions, you react it with the sulfate ions to give you your insoluble salt, which is lead 2 sulfate. And this is our ionic equation. So that is how you write an ionic equation. So maybe we can proceed and write the second one, which is the reaction between zinc sulfate and barium nitrate. So we can just rewrite it here. So we say barium nitrate, you react it, it is aqueous because all nitrate salts are soluble. Zinc sulfate also. So we are going to have the exchange of anions, the negatively charged ions, these ones and these ones. We are going to swap them, okay, the way we swapped here. So we are going to form our insoluble salt, which is barium sulfate, because we said all sulfate salts are soluble except barium sulfate, lead 2 sulfate, and also calcium sulfate. So we are going to write barium sulfate here. So the product that you're going to get is barium sulfate, okay, plus zinc nitrate. So I'm going to write zinc nitrate. This is solid. So after you've done the whole writing, the equation writing, you balance it out. So it is balanced in this case. The next thing is you write the ions present in our equation. You break it down. So we are going to break it down in this way. So the ions here are good. We have barium. The other one that we have is what? The nitrate ions plus zinc ions. I can see you understood, yeah? Plus, okay. Plus what? Yes, this retains the way it is, it stays like that because it is a solid, so we don't break it down. Plus, yes, you get your zinc ions there, plus your nitrate ions there. That is aqueous. This is also what? It's also aqueous. The next thing we do is we balance. After we balance, we're going to balance by putting A2 there and R2 there. We check for what next? Good. Spectator ions, the ones that did not change. And we are being shown that guided by the state symbol. So which ones didn't change? It is zinc, nitrate, zinc and the nitrate ions. So our ionic equation is going to be written like so, like that. So you get your barium what? You get your barium sulfate. Okay, so this is our ionic equation. So that is how you write an ionic equation, and that is how you prepare an insoluble salt. Okay, we've said in summary, for you to prepare an insoluble salt, you can either use direct synthesis, we've talked about it, and also double decomposition or double dissociation, or what you call precipitation reaction.